Assalamu alaikum warahmatullahi wabarakatuh. Good morning. I hope everyone is doing well. My name is Nusaybah Alghanmi and a PhD candidate in Information Technology Department. Today I will present the poster of our published paper which was done under the supervision of Dr. Rima Latebia and Dr. Sultan al-Shammari. And this paper has been published in Applied Intelligence, which is a Q2 journal. The paper is titled with the Population Affinity Propagation Approach for Points of Dispensing Location Allocation. So let me start with the introduction with the abstract for this work. Firstly, what are points of dispensing, or POTS as mentioned in the title? Points of dispensing are location for distributing medical services such as vaccines or even drugs during public health emergencies such as pandemics like COVID-19 to a large number of people while meeting a specific time constraint. These spots need to be sited in optimal locations and also have people or demand points or population assigned to them simultaneously, and this is known in the computer science field as a location allocation problem. This study does not rely on predetermined inputs such as a travel distance or the human intervention to decide the number of the puts. So this study does not rely on predetermined input to determine the number and location of puts as existing approaches. So for this reason, we propose puts LA, or puts location allocation algorithm, based on our population affinity propagation, or our novel population affinity propagation PAP, which is a clustering approach. And this is a clustering approach, or PAP. We include the population size as a design parameter to decide the number, or to designate the number and location of puts, in addition to geographical information. So regarding the research methodology, we have three main steps. The first step involves selecting the data sets. We select three data sets, including a real case, and this is we conducted a real case study for Jeddah during COVID-19, collecting data from for districts, for population size, and for COVID-19 vaccine centers from different trusted sources. Then in the next step, we propose puts LA as shown here in the figure 2. In the figure 2, as an input, for the puts LA, as an input we need the demand points location and the population size. And we have two phases in this approach. The phase number 1 designating the number and location of puts, and in this phase we have three main steps. Two of them, it's a pre-processing step to prepare the data for the population affinity propagation, and also as an output we will have the number and location of puts. In the second phase, we allocate the demand points to the nearest puts. We mean by the nearest based on the minimum distance. As an output for this work, we have the number and location allocation of puts. We use different back to the research methodology, we use different evaluation metric such as coverage and distance, and for the real case study we use the predictive performance. Let's go to the results. For the puts LA outperform other methods in terms of coverage as shown here in the figure 3. We mean by the coverage, it's how many of population are covered within different distance threshold from 1 to 10 miles, and we can see that PAP in the puts LA outperform other clustering methods in terms of the coverage. For the real case study, we can see that here in the Jeddah COVID-19 vaccine centers, or here is the Jeddah COVID vaccination centers that we collected from Ministry of Health, and here is the identified put that we identified by our put LA. We can see that in the there is a high level of allocation agreement compared to the other methods. We mean how many of identified and actual puts are located on the same district, as we can see here in the location agreement between the identified and the actual case, or the Jeddah COVID-19 vaccination centers. Unfortunately, due to the limited time, I'm not able to present the whole results, or even the application study. But if you are interested, for gaining more information about this work, I really recommend to you to to go to see the paper. In conclusion, the proposed approach will help the decision makers, such as the health authorities, for example, the Ministry of Health, to decide the number of pods and the location of pods without using any validation methods or even human intervention. To have more information about the paper, here is the QR code for the paper. If you to gain more information and to see the results also. If you would like to see or to replicate the work, here is the QR for the source code. Uh, if you have any information, or if you have any question, I look forward to sharing more details with you, and welcome any question or discussion via the email. And you can go to the paper, scan the QR code, and send me the email. Thank you for your time. Thank you for your attention. I hope everything was clear to you. And have a good day, inshallah.